Now, at least, I'm going to check this real quick and make sure it's still working. Yeah, cool. At least there's 52 of you. At least 50 of you have been asking yourself, okay, I can factor, I can FOIL, why do I care, why does it matter, I hate this, blah, blah, blah. 2 of you are real nerdy like me, and so you don't need a reason. You're just told to do something, and you're like, yeah, cool, I can do this, yeah, it's a game. So I'm going to give you a reason, all right? If I want to solve an equation, if an equation is set equal to 0 and I want to solve it, which is useful in many situations, and we'll talk about those in class. But if I want to solve something, for example, how long does it take for a ball that is thrown from a roof to hit the ground? We could use this. If I wanted to find out how many whatchamacallits I had to sell to break even in my new business, I could use this. All right? You would have to solve an equation. Let me give you an example of an equation. X squared plus 7x plus 10 equals 0. Okay, well, if I set this equal to 0 and I wanted to solve this and figure out what x do I have to put in here to make this 0? What x do I have to put in here to make this 0? There's a principle of zero products rule, which basically says this: a times b equals 0. If a times b equals 0, then a equals 0 or b equals 0. And we use that to solve this. So let's factor this. X is up front. What multiplies together to give 10 and adds together to give 7? How about 5 and 2? And we know that they're both going to be plus signs. All right? I know that equals 0. Well, if this times this equals 0, then that means that this guy equals 0, or this guy equals 0. So let's say x plus 5 equals 0, or x plus 2 equals 0. And then I can just solve. Those are my 2 answers, and I can plug them back in to check. So let's go back into our original equation. If I put a negative 2 in here, negative 2 squared is 4, plus 7 times a negative 2 is a negative 14. That would be a negative 10. Negative 10 plus 10 equals 0, and the same for negative 5. Okay? So that's what we're doing. That's how we're using them to solve. Let's do another example. X squared minus x equals 6. Okay? Well, it's kind of weird. Doesn't look like we normally, so I'm going to set it equal to 0. So I'm going to take that 6 and move it over. So x squared minus x minus 6 equals 0. And then factor it like I love to do. X is up front. 3 and 2. And the biggest one gets the sign. And if you look at that, negative 3x, positive 2x, that's negative x, negative 6, x squared. So it all works out. And now I set each one of these equal to 0. Those are my 2 answers. Okay? Let's do another one. F of x equals x minus 2 over x squared plus 2x minus 15. Now, the problem in this asks me what the domain is. That means what x's am I allowed to put in here? Well, why would you have a limitation of what x you could put in here, right? That doesn't really make sense unless you remember the bottom of a fraction can never equal 0. It can never equal 0. If it equals 0, the world explodes. Okay, that's why it can never, because you can't divide by 0, because if I have a pie and I'm dividing the pie between 4 people, everyone's going to get a fourth. If I divide the pie between 17 people, everyone's going to get a 17th. If I divide the pie between 1 person, that means I get to keep the entire pie, which is awesome. If I divide the pi by no one, it doesn't make sense because you would want to say, okay, it's 0, but that means the pi doesn't even exist anymore. Where did the pi go? No one knows. That's why you can't divide by 0. The world explodes and there's no more pi. So if this can equal 0, watch this. X squared plus 2x minus 15 cannot equal 0. Well, let's solve it. X is up front, and then I happen to know that 3 and 5 make 15. Big one gets the sign. Big one gets the sign. And then I solve. X plus 5 cannot equal 0. X minus 3 cannot equal 0. Minus 5 plus 3, x cannot equal negative 5, x cannot equal 3. So those are my limitations. Isn't that great? I can tell you're all super excited about this. Now, there's one more example that I'm going to show you. And this is kind of a special case, but it's important. F of x equals 3x cubed minus 30x. G of x equals 9x squared. What it's asking is when are these equal? At what x are these equal? Okay? Well, it seems kind of complicated, and it will be complicated if you complicate it. But if you think, okay, I've been solving a lot of these where you just set them equal to each other or move them all over to one side and set it to 0 and solve. So I bet that's what's going on here. It is what's going on here. So if these are equal to each other, then that means that this equals this. So let's write that. 3x cubed minus 30x equals 9x squared. Now, I want to solve this. So I set it all equal to 0. So I'm going to subtract that 9x over. Okay, so 3x cubed minus 9x squared minus 30x equals 0. Now, before I do anything, I need to see if there's anything that I can factor. Is there anything that all of these share? Well, they all have a 3, and they all have an x. So I'm going to take out a 3x. That's going to leave me x squared minus 3x minus 10, which makes my life so much easier. And then I'm going to factor that. X is up front, 5 and 2. Big one gets the sign. Okay? Now, I have 3 different options that could be 0. This could be 0, this could be 0, or this could be 0. So I've got 3 equations. 3x equals 0, x minus 5 equals 0, x plus 2 equals 0. Divided by 3, divided by 3. What's 0 divided by 3? It's 0. So x equals 0, or plus 5, x equals 5. That's another option. Minus 2, x equals negative 2. That's my third option. I have 3 options. Now watch this. What is the degree of this polynomial? Remember from 5.1, what is the degree of this polynomial? Well, the degree of this monomial is 1. The degree of this one is 2. The degree of this one is 3. And the highest one is the degree of the whole thing. So the degree of this polynomial is 3. How many answers do I have? 3. Not a coincidence. That's how it goes. All right? And that is 5.8 in the end of chapter 5. And you're all going to do great on your test.